This video we're going to walk through the Unit 8 Bellwork, which involves volume by disk, washer, and shell methods. Number 1 asks us to find the volume of the region bounded by f of x equals 3x minus 2, g of x equals 6 minus x, and x equals 0 that is revolved around the y-axis. As soon as you read that last part where it mentions we're revolving around the y-axis, because the y-axis is vertical, you automatically should be thinking to use the shell method. Before you even get there though, you have to decide what your region looks like. So I'm going to jump to the solutions here. And you can see I drew a picture. So f of x is 3x minus 2, y-intercept of negative 2, slope of 3, so we've got the line right here. G of x equals 6 minus x, so y-intercept of 6 with a slope of negative 1, line there. And it's pretty easy to see that they intersect at x equals 2. And because x equals 0 is one of our other boundaries, we've got this sort of triangular region. Well, not sort of, it is a triangular region. And we're revolving that around the y-axis. Shell method is based on the geometric formula 2 pi times the radius times the height times the width. So the 2 pi goes out front. The integral is from 0 to 2 because those are the x values of the region that we are revolving. Our radius is pretty simple in this case. I'll draw it in here, but it is from any arbitrary cross-section back to the region we're revolving around. So because it's coming right back to the y-axis, that is a radius of x. And our height is simply the upper function minus the lower function, which is where the 6 minus x minus 3x minus 2 comes from. This question could be calculator or non-calculator. I treated it as a non-calculator question. So 6 minus x, distribute the negative here, so you end up getting negative x minus 3x is negative 4x. 6 minus a negative 2 is really 6 plus 2. So we've got 8 minus 4x for our height. When we distribute the radius of x, we get 8x minus 4x squared. So here's the function we're going to integrate. Pretty simple to integrate. X goes up to x squared times 1/2, which is where we get the 4x squared from. X squared goes up to x cubed times 1/3, which is where the minus 4/3 x to the third power comes from. And when we evaluate upper limit minus lower limit, I didn't show my work for it, but if you simplify correctly and then multiply by the 2 pi out front, you get 32 pi over 3. Nice little example of the shell method. Pretty straightforward to follow. And then there's question number 2. Question number 2 says, suppose a region is bounded by f of x equals x cubed, g of x equals 0, and x equals 1. Find the volume of the solid created when the region is revolved around each line. So this is a multiple part question. However, this time we are just setting up and not solving the integrals. So you are asked 5 different questions. A asks to revolve around the x-axis. Immediately, x-axis is horizontal, so we're thinking disk or washer. Part B says around the y-axis. Immediately, since it's a vertical line, we're thinking gotta use shell. Part C around x equals 2, another vertical line, so we're going to do shell once again. And then both D and E are horizontal lines, so it's either disk or washer. Our basis of whether disk or washer and how we determine our radius for the shell is going to be determined by our picture. So if I jump to the solutions, let me minimize this. Let's see if I can get it all in the same window here. One more. Oh, there's an F. f is around x equals -3, so I'm going to recant my previous statement. Let's go back to the Bellwork document. Scroll down a little bit more. I didn't see that f there. So f is around x equals -3, another vertical line, so we have to do the shell method for part f. So part A, disk or washer. Part B, shell. Part C, shell. Both D and E will be disk or washer, and f is going to be shell. Once you get a picture, you can get a pretty good idea of how each one of these is set up. So I had to be kind of small with my picture because, going back to the region, x cubed is the curve that goes through the origin and then comes up. G of x equals 0, that's just the x-axis, and x equals 1 is that vertical line. So the region we're looking at is that tiny little shaded region you can see there. Once you have that region, you can draw in your various lines that you're revolving around. So for part A, if we're revolving this region around the x-axis, we knew that it was going to be disk or washer because it's right up against the x-axis and there's no gap. This is a disk. So the disk formula is based on the geometric formula, pi r squared times the height. So pi goes out front. The integral is from 0 to 1 because those are the x values that we are integrating over. And our radius is x cubed because that is our function back to the x-axis. We have to square it, and then the dx takes care of our height. So pi r squared times height. Nice, easy little setup. Part B, also pretty easy. We're revolving this one around the y-axis. So the region right here revolved around the y-axis. All we have to determine really is what our radius and height are, because the geometric formula that shell is based on is 2 pi times the radius times the height times the width. So the 2 pi goes out front. The integral is still from 0 to 1 because our region hasn't changed, so our x values are still 0 to 1. Our radius, if I draw in from a arbitrary cross-section back to the y-axis, that is just x. Doesn't matter where you draw it, the distance is from 0 to wherever your x value is. So the radius is x. The height is simply x cubed because we're going from our f function back to the x-axis, and the width is dx. So a pretty simple integral for part B. Part C, we're now going to revolve around x equals 2. X equals 2 is the vertical line that you can see dashed in here. We're taking this region and revolving around that. Because we're revolving around a vertical line, we automatically are going to the shell method. So once again, the geometric formula is 2 pi times the radius times the height times the width. 2 pi goes out front. The integral is from 0 to 1 because those are the x values that we are integrating over. Our radius, if we draw on a radius here, we go from an arbitrary cross-section to the axis we're revolving around. Now we cannot call that x. X would be the distance from our cross-section back to the y-axis. So if that's x, and the distance from the y-axis to what we're revolving around is 2, then our radius here is 2 minus x. So 2 pi times the integral from 0 to 1 of our radius times our height, which is still just going to be x cubed dx. Pretty nice, easy setup once you get the hang of it. Part D asks us to revolve around y equals 2. Y equals 2 is a horizontal line. So now we're thinking disk or washer. You can see that the region back up over y equals 2, there's a gap, so this is definitely a washer. What we have to decide is what's our outer radius and what's our inner radius. So remember, your outer radius is which part of your region is farther from what you're revolving around. So I go from this part of the region up, and my outer radius is 2. My inner radius goes from the curve up to y equals 2. But I can't just call that my function x cubed, because my function x cubed would be from the function down to the x-axis. So if 2 to the x-axis is always 2, and my function to the x-axis is x cubed, then my inner radius is 2 minus x cubed. So for a washer, we do pi times the integral from 0 to 1, because our region is still the same, of our outer radius, 2 squared, minus our inner radius, 2 minus x cubed squared, and then of course dx. Part E, we're revolving around y equals -4. So now we're taking our region and we're revolving it all the way down and over y equals -4. This time our outer radius, the farther portion of our region, goes from x cubed past the x-axis all the way down to y equals -4. So it's going to be x cubed plus 4. Our inner radius is simply the x-axis down to 4, -4, but the distance is still 4. So our integral is pi times the integral from 0 to 1 of our outer radius, x cubed plus 4 squared, minus our inner radius, which is just 4 squared dx. Our last question, around x equals -3. X equals -3 is over here. It's a vertical line, so we know we got to use the shell method. Shell method, once again, is based on the geometric formula, 2 pi times the radius times the height times the width. So 2 pi goes out front. The region we're integrating is still from 0 to 1, so our limits don't change. Our radius, however, if we take a cross section and go past the y-axis, excuse me, to -3, is going to be 3 plus x, and then our height is still just x cubed. So our final integral for part F is 2 pi times the integral from 0 to 1 of our radius, 3 plus x, times our height, x cubed, dx. You could actually integrate all of these, but in this case it was just asking us to set up and not solve.